and welcome to today's mathematics class. Today's class we'll look at the study of probability. I'll take my time as much as possible to break down this topic, right? So first things first, we'll look at probability definition, right? The basic terms used in probability. Then we'll also look at calculations that could be possibly done using the basic ideas of probability. In our next video, we'll look at the probability formula, right? So for now, let's focus on definitions, basic terminologies, and the formula to probability, and then we'll move on to the next concept there. So first things first, I'll try as much as possible. If you are watching this video, no doubt today will be the day that you understand probability once and for all, right? So definition, please. Probability of an event is a measure of the likelihood of that event occurring. I said probability of an event is a measure of the likelihood of that event occurring. Full stop. That is how you define probability, basically, right? So at this junction here, we have know the definition to probability, right? We said it is a measure of the likelihood of that event occurring, or perhaps of an event occurring. At this junction here, please note that the probability of any event, the probability P of any event, let's say in this case we are using event A. In probability, we have different events. We can have event A, event B, event C. Now that event, there is something that is used to represent every event. So this, if I have A now, event A could mean 1, 2, 3. So let's say you have 1, 2, 3. So you can use 1, 2, 3. You can use event A to represent 1, 2, 3. So whatever you are seeing here is just a representation of something. So event is simply what there, a representation of something. So if I have probability of an event A, and you can't find probability unless that thing is an event. So I'm saying this, please. The formula attached to this, please. The probability of any event, I'm assuming in this case event A, will be equal to all possible outcome of that event, right? All possible outcome of that event, in this case event A. So more of like saying all possible outcome of event A, but in this case here, because I want to generalize it, all possible outcome of that event, all over total possible, or total outcome, total outcome, all over total outcome. Alright, this becomes your formula to probability. So given the probability of an event, I'm choosing in this case, let me use event A. I could put B, I could put C, whichever thing there can be here. But note that is equal to all possible outcome of that event, right? All over total outcome, right? So this total outcome can also be known as sample space. So I can call total outcome, just watch out, total outcome, I can call it what there? Sample space. We'll look at what sample space means as we proceed in the basic terms involved in probability. Please just wait. Yes, I there. If you learn something new, right, at the very first day, you learn something new, it will look somehow confusing. Understanding it small, you won't really get it properly. Or just hang on, watch, write your notes down, understand what I'm explaining. After you have watched the video, you can rewatch it again. Then you now understand it properly. But at the first, this is the first time here. Just hold on, learn first. After learning, then revise, rewatch the videos. Then it will increase your in-depth understanding of this concept here. So this is what you have here. Please, I'm saying this, please. Total outcome, I can probably call it what the sample space, right? So at this junction here, let's look at, having established the formula for probability, let's look at the concept of basic terms involved in the study of probability. So, terminology, basic terminology involved in the study of probability. These are things, these are words, the words we'll be using in probability, right? Number one there, please. Number one, experiment. Experiment. All right. The first term is called experiment. Definition, please. Any well-defined process that yields a result. I said any well-defined process that yields a result or an observation. Example are tossing a coins, throwing a dice. So this is how you define experiment. So any process that yields a result or an observation is called what there is called experiment. That's how you define the first terminology in the study of probability. Number two there is called outcome. Outcome. The second term is called outcome. What's an outcome? Definition, please. A particular result of an experiment. I said a particular result of an experiment. So I'm saying is please that outcome is simply a result of of this experiment. So the result you get after experimenting something is called what that is called the outcome. Please take this thing serious. Number two. Number three, please. Number three. The third terminology there is called sample space. Alright. Sample space. Alright, so here. You know, I said that I can call my total outcome to be sample space. Now, what then is sample space? I am begging you. Sample space will be used more as we proceed, please. Sample space will be used more as we proceed. I'll give you definition now. Read it, call it out, like define it, and don't just read it with your mind. Like pronounce them out. Read it so that your ear, your body can sense what you are saying. Right? Sample space, please. Definition, please. Sample space, please. The set of all possible outcome of an experiment. Sample space. This is the set. So the set of all possible outcome of an experiment. That's sample space. Alright, now listen guys, let me just take you back to something. Don't just capture your mind on what sample space looks like. So let's say we have a classroom like this. We have girls to be 50. We have boys to be 50. Please, boys and girls are 50-50, right? Now, the sample space in the classroom is 100. So sample space does not focus on boy or girl. It focuses on what everybody. So what sample space is after is that if I come to the class, I'm not looking at boy or girl. How many are there in total? That's sample space. Also called what total outcome. So if I come to a class, if I ask class, what is your total outcome here? I don't want them to give me, okay, we have boys to be 50. No, give me 100. So total outcome or sample space simply means the total of every freaking body, right, in that classroom. That classroom case. When we look at example, you understand what I mean by sample space. But to capture the idea, that is what sample space simply means, right? The total of all what's it called there, of all possible outcome of an experiment. That's how you define sample space, right? And obviously you can see my definition. I mentioned outcome. My definition. That's this, please. At this junction there, let's look at the fourth terminology, the fourth one, called sample points. Sample point. Sample point. What is a sample point? Definition, please. The individual outcome is a sample space. The individual outcome in a sample space. Sample point is simply the individual outcome in a sample space. That is what we call sample points. Oh, sorry. A sample point. Yes, sample point. All right. The fifth one, which is the last one on my list here. Let's have events. What's an event? Because we said the probability of an event or of any event is equal to all possible outcome of that event, all over what the total outcome. Total outcome is also called total sample space, or 1 2 aka sample space. Now, what's an event? When we say event A, event B, or whatever, what's an event? Let's define event, please. Event, please. Definition, please. What's an event? Definition. An event, please put down, please. Any subset of the sample space. Any subset of the sample space is called an event. I said any subset of the sample space is called an event, comma. If A is an event, then n of A is the number of sample points that belongs to event A. That is how you define the concept behind event. Now, according to research, before I start teaching, I try to make research. Now, how can I possibly teach my students probability in such a way that they'll feel satisfied? How good, guys? So, definition, basic term, done. There is something we need to discuss now. If you're familiar with probability before, right, you will observe that in probability questions, even if you're not familiar with probability, one check some few questions there. You'll be saying coins. You hear the word coins. You hear the word dice. You hear the word what's it called there? What's this thing there? Card. Yes, card. You hear the word card. You know, in a card we have the diamond, the spade, the club, and the heart, right? That's, you're hearing that too. You're hearing what's it called? Different objects, right? The one you hear most is coins and dice, right? You won't hear this or the one of the card. You're hearing card. So the probability focus, there are some objects that probability usually use to give you questions, right? So we'll now look at this object, like the definition of the object, what to look out for in the object, what to be familiar with about that object, so that whenever you see question, you can easily undo that question using that idea you have known about it. If I come here now and give you a question on coins, some people don't know that, some people don't know something about coins, so which I have to discuss now. If I come here and give you a question about card, some people don't know something, some people don't know much about card, right? Some people have never played card before. So you need to understand what this object means first before you start solving what the problem about them. So that's what we want to look at now. So let's look at object use in probability, please. Object use in probability, please. Object used in probability. So let's look at the object. All right. Number one there. Let's start the first one there. Let's start the first one. Coins. I won't take everything, but at least I'll show you the most popular objects used, and I'll explain them to you. Let's have a coins, please. Number one, coins, please. What's a coin? A coin is a small flat piece of metal used as money in many countries. Full stop. The probability, in probability, a coin is used because it has two distinct sides. Full stop. That is what a coin means. A coins is a money. We all know coins is money in some countries, right? Now, why coins? Why coins? Why coins? Why not biscuit? Why not pure water? Why not nylon? Why coins? Why is coins used probability? Because it has what there? It has two distinct sides. No, in coins, there are two faces. Let's say I have this a coins now. To have a face here and a face here. Because it has that two faces, that is why I am interested in it. That is why probability is actually interested in coin, right? Whenever something has distinct sides, then probability love that thing much more better, right? So that's by the way about coins there. Now, what are the key take to note in coins? Whenever you see a question under probability and it focuses on coins, what are the things that I need to digest in me before I can answer that question? Please note. Under coins, please note. Under coins, please note. Please note. A coins has two faces. A coins has two faces. Very important, please. Which include the head, that's H, and tail, that's T. Alright. Head and tail. So number one, please note that a coin has two faces. It has the head and the tail, right? Please, as you're watching my video, I'll display what I'm saying. Just check, you see everything, don't worry. So that's what I'm saying, that a coin has an head and tail, right? This one there, that's the first thing to note. That's note number one, please. Note number one. Note number two on that coin, please. Note number two. Note number two, please, on that coin. When a fair coin is touched once, comma, there are only two possible outcomes. There are only two possible outcomes: head or tail, comma. Both outcomes are equal likely, comma. The sample space is head, comma, tail. So we're saying that the sample space of a coin is head, comma, tail. Alright. Head, comma, tail. And please, in probability, we don't use round bracket. We don't use square bracket. We use what there? A coney bracket. Observe, please. See this. This one here is you should be familiar with this one. In set, you do this bracket in set. So they're using this bracket that is for set in probability too. So you can see that the sample space. When I say sample space, if I have a coin, if I throw a coin up, there's high chance I get head or tail. Aside head and tail, nothing else in a coin. So I define sample space for you as what the all possible outcome of that event or that experiment. So if I throw my coins, the possible outcome I can get from a coin is head and tail. That's what I mean. Sample space is what the head, comma, tail. That is how this concept works. This is what I want you to note in the study of coin, that the sample space of a coin is head and tail. That in a coin has two faces. It has the head and the tail. That is what I want you to understand as we proceed in the study of other objects. Now I'll display a video that you can. I'll display a video that shows the virtual the physical let's say a display of a coin, both the head and the tail. So you can see it. You know, seeing is believing for some people. So I will show you in You see it now.
Here is a coin. One side is called heads and the other side is called tails. When we toss a coin, either heads or tails can occur.
All right, let's look at. I haven't watched the video on coin. Let's look at the next one called dice. So what's the dice? Let's look at dice. Second object, please, called dice. Let's do dice. Dice, dice, dice. All right. Number 2, coin is done. Let's do dice. Right. So what's the dice, please? What's the dice? Now let's call dice. A die, please listen and listen for proceed, please. Dice is the plural form. Die, D-I-E, is a singular form. Now put on, please. A die which is also called dice, is a small cube used in games. Stop. Each faces is marked with dots representing numbers. That's how you define a die. I'll have to show you the video of dice. Don't worry. Just let's do theory part first. Now we all know dice. That dice is something like, is a cube stuff, and it has dots. Right? In some faces of the cube. I think that's 6 faces there. 6 faces in a cube. One is having 1 dot, 2 dots, 3 dots, 4 dots, and like that to 6 dots. Right? Now I'm saying this, please. What I want you to take home from this dice is this. Whenever I see a question on probability that focus on dice, these are the things that I want you to remember instantly, so you can tackle that question. Now, note, please. Note. One, note, please. Note A. Under A. Note, please. A. A standard dice has 6 faces. A, please note. A standard dice has 6 faces, please. B. The faces are numbered 1, 2, 3, 4, 5, 6. The faces are numbered 1, 2, 3, 4, 5, 6. C. Note number C. Note letter C. Each number has an equal chance of appearing when the dice is rolled. D. The sample space is 1, 2, 3, 4, 5, 6. That's the sample space for a dice, please. I've given you A, B, C, D stuff to note. Now, a dice has 6 faces. As we know, this dice that has 6 faces, the faces are numbered 1, 2, 3, 4, 5, 6, right? So let's say, okay, don't worry, I'll show you the video to dice so you can see what I'm saying, right? Also, each number has an equal chance of appearing when a dice is rolled. That's true. You know that. Also, please note that the sample space, please. The sample space of a die is what? 1, 2, 3, 4, 5, 6. Because that dice has 6 faces and each of the faces has 1, 2, 3, 4, 5, 6. So the total outcome, literally in a dice, if I throw a dice left and right, if I take the dice like this and throw it on the floor, the highest outcome I will see is 6. So likewise, a coin, if I throw a coin has only two faces there, head and tail. That's the highest outcome, the total outcome. You know the way I explained the idea of boy and girl in the class for you. So literally, for dice too, if I throw a dice, no matter how I throw the dice, the highest outcome there is 1 to 6, right? Nothing else. There's no 7 there, there's no 8. Highest is 1 to 6, and that's it. Your sample space for a die is what? 1 to 6. That is another object being discussed successfully. Number 3, please. Of the 3.
This is a die. A standard die has 6 faces, numbered from 1 to 6. When we roll it, any number from 1 to 6 can occur.
It's called colored color balls in a bag. Yes, on that kind of what's it called? Kind of object they do use is called colored ball in a bag. I think something like there's a basket of blue, red, and green ball are to be picked at random. What is the probability of picking red ball? You know that idea comes with this, please. Colored ball in a bag. At this junction here, what does this mean? Put up, please. A bag of colored ball is commonly used to illustrate random selection in probability. Stop. One ball is picked without looking. One ball is picked without looking. Full stop. Alright, that's how you define that stuff there, right? Literally. Now, for every object, I give definition and I give you the main thing to go and look out for. Like the thing to digest in you. Literally, for dice, I give definition, I give you what to digest. Now, for colored ball in a bag, I give you definition. Now, what are the things to digest in you? Whenever I see maybe a red ball, a blue ball, whatever idea that has to come with red and blue concepts, what are your key take home here? I'm giving you 4 take home here. Now, note please, note the following, please. Note. I'll give you A to D the way I did for dice. A to D here too. Put up, please. A. Note A, please. Count the total number of ball. Number 1, your first thing to do first is what? Number 1, please. Count the total number of ball. Number 2, B. Next thing, please. B. Count how many ball belongs to each color. C. Every ball has an equal chance of being selected. If they are identical, except for colors. D. The probability depends on the number of ball of the required color compared to the total number of the ball. Alright, these are what I want you to note in the cost of color ball. In a color ball, your first task is to check how many balls are there in total. Don't focus your mind on if it's green or red or blue. How many are the color in total? When you have done that, then segment them. Next is to do, how many red do we have? How many blue do we have? How many pink do we have? And from there, you can move on solving the problem. Please, these are the things to note when it comes to color ball in a bag. The next thing there is called playing card. That card we do play. Oh, before we move on to the next stuff there, let me display what I mean by color ball in a bag.
Here we have colored balls inside a bag. If we select one ball without looking, the color we get is an outcome of the experiment.
Number 4, we said that's a playing card. Number 4, playing card. Let me even check my camera. Is it recording? Okay, recording. That's cool. Alright, let's do playing card, please. Playing card. You all know playing card now. You should know playing card, right? Let's define playing card, please. It is called close. Okay, put down, please. A desk. A deck of playing card is another common probability too. A deck of playing card is another common probability too. You should also know about, right? Let me give you the key important things to note in a playing card. Please note the following, please. Number 1, A standard deck contain 52 cards. So that playing card, the total in the carton is 52. Okay. A standard deck contain what there? 25 cards, right? Number 1 to note. Number 2, there are 4 suits. There are 4 suits there. We have the heart. We have the hearts. Of course, something like this. We have the hearts. We have diamond. Something like this, right? We also have the club, something like this. We have the club, and we have the spade, something like this. In case I'm not correct, go on Google and search them. You will see the clear diagram. Sorry for my diagram. So in this playing card, we said total of all the card inside in the carton. If you buy new one, the total is 52 in the inside, right? Now that 52 that is inside, there are now 4 categories inside. We have the heart, we have the diamond, we have the club, and we have the spade. Now you see these hearts and diamond, they are red. Why this spade and club are what there are black? Please note that one first, right? So note that one first, that heart and diamond are the red one. They are red in color, while club and spade are black in color. Now why 52? Why the 52? Because you see this heart alone, the card of heart alone is 13. The card of diamond alone is 13. The total number of club that we have in that the 2 is 13 too. Total number of spade in that card is 13 too. So 13 plus 13 plus 13 plus 13 gives you a total of what there of 52. Know this thing, please. Very important. So this is what I want you to note in the study of what the card. And don't forget again, something again to note. Don't forget this, please. Know this one too. That each of them, like for each of the cards you are seeing here, let's say for heart, for instance, for heart, right? Heart has, these are what heart contain. We have A, 2, 3, 4, 5, 6, 7, 8, 9. We have 10. We have J, Q, and we have K. And if we count them all, is that 13 in numbers, right? We count them all, they are 13 numbers. So we said heart is 13, diamond is 13, club is 13, spade is 13. What is the thing that made them 13? This is it here. So for heart has A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then J, Q, K. So all this you are seeing, this is card, they are card. So the way heart has this, that is the same way diamond heart has its own, the same way club has its own, the same way spade has its own. So total of 52. This is what I want you to note in the study of what's it called there? In the study of playing cards as one of the objects used in probability. I'll list out the next two, but I won't give you, just make research on them on your own.
These are playing cards. We can select a card randomly from a deck, and the card we select becomes the outcome of our experiment.
Number 5, the fifth card object used is called spinner. Spinner, right? You know spinner now. I'll show you the video of spinner. You see it now. So a spinner is just more of like you trying to spin something to get to a particular object or to choose something. I think if you are playing game, if you are playing game very well, you see spin, it will now start rolling, and there will be something like a pencil that will stand like this, and when you spin that stuff, it will roll. So anywhere the pencil lies on, that is what you are picking as your gift, something like that. I'll display the video. Just watch the video, you see, understand what I mean by spinner.
This is a spinner. When we spin it, the pointer can stop on any of the sections. The section where it stops is the outcome.
Also, number 6, please. Number 6, we have number or letter card. We have number, call it number or letter card. This is also another object to also note the study of what there of probability.
These are number and letter cards. If we choose one card at random, the number or letter on the selected card is the outcome.
Right? So, having said this, we have done the basic introduction to probability. At this junction, let's solve some examples, please. In the study of probability, let's solve some examples here. Let's solve some examples here. Are we ready, guys? I will not do the example now. So watch out for the part 2 of this video, please. Watch out for the part 2 of this video. In that part 2, we'll now solve example. Please, I will advise you, check the part 2 on my YouTube channel. Alright. Perhaps I remember, I'll leave the link. Sometimes I don't remember, sometimes I don't remember. I'll leave the link of part 2 in the video description. So check it there. If it's there, click on it. If it's not there, you will see it. YouTube will recommend it for you. Right? So that's the basic thing I can give here for introduction to probability. Right. So let's move on to solving some simple problems in the study of probability. Let's do examples.